Let's start hooking things up and operating our high voltage plasma. We are going to take things step by step still, so let's not get too crazy. Because we need to actually understand what voltage is, what an electrical current is, and what resistance is. Here I got my multimeter, and I got my Variac transformer. I have a power cord right here. The ground of the power cord has been taped off, and the live and neutral wires are connected up to the two leads of my multimeter that came with the multimeter. Here I can change the settings, the different voltages. Mine is randomly reading voltages. I don't necessarily know why. So I have it set to the 200 volts alternating current, because that's what's going to be coming out of the wall and into the Variac. Powering on my Variac, should now be able to turn the top of my Variac and increase and decrease the voltage. As you can see, we're going up 70, 112, just coming. Now, the thing about this voltage right here that we have, there's no actual electrical current flowing. There might be a tiny bit flowing through the multimeter in order to gauge a reading of the voltage, but the potential actually exists between the two wires, which I'm going to turn this down now. These two wires, and if I were to connect them, the electrical current would finally flow through that circuit that I made by connecting them. The current would flow at the voltage that we saw here. The voltage might drop as the current flows, and that's all the nuance of electricity, but that's a basic discussion of. Now, just like before, I have my multimeter connected to the input of my high voltage transformer, and I have right here my high voltage leads that I had connected up to the high voltage leads on the transformer. They're very close together up here, and what I'm going to do is I'm actually going to create what is called a short circuit through the air. The reason it's called a short circuit is because it essentially has the least resistance value that could possibly, like, circuits want to flow along a path where they're actually going to be doing work, and if they're just flowing through a wire from one positive terminal to the next, that is considered a short circuit because there's almost no resistance, and when that happens, because voltage, current, and resistance are all related, the voltage will essentially be the current, and it is really, really high. I'm going to walk over to my Variac and start increasing the voltage to my high voltage transformer to create the high voltage short circuit. And I'm also taking precaution not to touch anything and making sure that everything's clear of any metal rods. Now that the plasma is going, I can actually decrease my voltage a little bit, and we can learn a little bit more about plasma. Increasing it back up again. If I just left it, it would keep going, but I'm slowly decreasing. Because when the current flows in the plasma, I guess there's less resistance, and so it can continue to flow. This is how fluorescent lights work, by igniting the light and then maintaining the light with a lower voltage. The reason I wanted to do that short circuit experiment is to demonstrate the importance of staying away from these high voltage leads. Those high voltage leads were able to break down the air about an inch or two in between those wires, and I wasn't even really at full power the first time I did it. So for you to get in the way, your body has such a lower resistance value than the air, and it can really, and you're connected to ground in an electrical circuit, so if your shoes aren't insulated you're basically just going to be going down because the circuit is going to complete itself through you and it won't be going through the air, and you will be the short circuit. So that's why it's very important to make sure you stay away from these high voltage leads and keep them free of objects. You also need to take precautions because the vacuum chamber itself can become part of this electrical circuit, I believe, because my vacuum plasma has done things that I can't really explain, but the best way to explain it is that my plasma wasn't happening inside of my chamber and I could see it going up into my vacuum chamber and not, where I wanted it. And I was sure as silver that, if I touched my vacuum manifold or my vacuum pump in any of the conductive areas, that I would have actually completed the electrical circuit and could have possibly shocked myself really bad. Because when working with lower voltage plasma chambers, like out of a plasma drivers out of a plasma ball, I've done that exact thing that I just described, where the plasma had ionized up above the chamber, and I touched it and shocked myself, and it was quite a surprise. So be very careful. So I got that valve right here, the pipe coming out of the vacuum pump, and right here I've got my digital vacuum gauge. So as the vacuum increases, these numbers will move around on here, similar to the multimeter, but it's displaying the vacuum level of vacuum. And I got my power line right here for my pump, so I'll go ahead and she's sucking out air. We're already climbing up to -25 whatever Hg, inches of mercury, and I'll come back when I'm at my full vacuum. Got the highest vacuum that I can achieve. Looked at the pressure outside, and it's about 30.15 Hg, so -29.34 is pretty close and seems pretty typical. Now I'm going to go ahead and flush a little bit of gas out of here, making sure that the valve is clear, because sometimes there'll be gas and moisture trapped in there, and I'll do the same with this guy. I can't even hear it. Not much to look at yet. You could do the experiment right now, but we're going to avoid messing up our vacuum pump at all by disconnecting this and running the experiment through the plasma without the pump involved. I have one of my high voltage leads connected at the base of my vacuum chamber through the iron nail, and the other high voltage lead here up at the valve. My vacuum chamber is disconnected from my vacuum pump. I'm now going to apply the high voltage to these leads and create a short circuit through the low pressure vacuum. Flipping on my Variac. I also have my multimeter right here. You can see that it takes a lot less power to make that baby flow through the vacuum. So it's about 6.6 right there. Doesn't take much. And to do an electrical cratering experiment, you would have simply added sand in there and it would have worked. I did my first experiments with this disconnected setup where my vacuum chamber was not connected to my pump. Then I started running experiments where I had a rubber tube connected as the craters were forming. The pump was running as well. And that's about it. You can adjust your Variac and look at your plasma. Don't touch it though.